With the quantum theory of nature, Max Planck came up with the idea that energy comes in certain bundles or packets. And there's an equation that we can use to calculate how much energy is in a particular packet. And that would be E equals h times nu. E stands for the amount of energy in the bundle, and we know energy is measured in joules. H is simply Planck's constant. That number never changes, and that is actually 6.6262 times 10 to the negative 34, and the units are joule seconds. Planck has a C in there as well, times frequency. And frequency is in hertz, or 1 over seconds. So again, noticing units, if you multiply 1 over seconds times joule seconds, the seconds cancel out, and you're left with joules, and that's what you measure energy in. So how do we do examples of this type of problem? Well, if I know the frequency, let's pretend the frequency happens to be 8.2 times 10 to the 15th hertz. How much energy is associated with a packet of light at that frequency? Well, this is very easy to do. Energy is just h times nu. Take your h, 6.6262 times 10 to the negative 34, times 8.2 times 10 to the 15th. You get joule seconds and 1 over seconds. When you multiply Planck's constant, 6.6262 times 10 to the negative 34 times the frequency, 8.2 times 10 to the 15th, you end up with 5.4 times 10 to the negative 18 joules of energy. So if you're given frequency measured in hertz, it's very easy to find energy. All you have to do is take your frequency times this constant. The other thing we might do is, instead of giving you frequency, we'll actually give you wavelength. Well, that's no big deal either. Let's pretend we know that light has a wavelength, or visible light has a wavelength somewhere between 700 nanometers and 400 nanometers. Let's find the energy associated with light at 480 nanometers. In this case, I'm given a wavelength, but I need to find energy, I need frequency. Well, no problem. I can do one of two things. I can either use this equation to change my wavelength into frequency, or I can substitute this equation for frequency. I think I'm going to do that way. If I look at my speed of light equation, frequency would equal c divided by lambda, just by dividing both sides by wavelength. Once I have that, I can substitute in for this equation, which means my energy really is h times c divided by lambda. And now I have an equation that relates energy to wavelength. So energy is h, the Planck's constant, 6.6262 times 10 to the negative 34 joule seconds, times c, which is the speed of light. That is 3 times 10 to the 8th meters per second, divided by wavelength. Well, you'll notice my seconds are going to cancel out. I want to end up with joules, which means my meters have to cancel out. In order for that to happen, this has to be in meters. What does the prefix nano mean? Well, nano really means 10 to the negative 9. So 480 nanometers is the same thing as writing 480 times 10 to the negative 9 meters. Now my meters will cancel out. Everything cancels out except for joules. If we multiply 6.6262 times 10 to the negative 34 times C, which is 3 times 10 to the 8th, and then divide it by 480 nanometers, or 480 times 10 to the negative 9 meters, we end up getting energy of 4.1 times 10 to the negative 19 joules. That is the amount of energy associated with light at 480 nanometers.